to secure your connection strings using the AWS Key Management Service. Hey everyone, my name is Brian Morrison and I'm on the developer education team here at PlanetScale. In this video, we're going to take a look at how you can use AWS Key Management Service, also known as KMS, to encrypt and secure your connection strings that are used within environment variables and Lambda functions. This is used as an extra layer of protection to prevent unauthorized access to those connection strings. Let's take a look. Okay, we're going to start inside of a terminal, and the first thing we're going to do is use the PlanetScale CLI to connect to a database I've already created called recipes_db. And I can do this with pscale, shell, recipes_db, and then main, which is the name of the branch. I'll hit enter and I'm dropped into a shell session for this particular database. And I'm going to paste in a script I have that will create a simple table that will be used to store our recipes. It's got 4 fields: an ID column, which acts as the primary key, a name for the recipe, an estimated time to make in minutes, which is an integer column, and description, which is an additional text field that can be used to describe the recipe. I'll hit enter to go ahead and create this table. We can check the structure of the table with describe recipes, and there are the 4 columns that were created. Next, I'm going to paste in another script, and this is going to insert a couple of rows into that table so we can return some data back into the Lambda function. I'll hit enter, and then I'm going to test this with select star from recipes, and there are the 3 rows that were just created. Now I'm over in VS Code, and I have an empty folder open where we're going to initialize the Go project that's going to hold the code for the Lambda function. I'm going to open up the integrated terminal, and I'll type in go mod init AWS KMS demo, and just make that the name of the project. Next, I'm going to create a file named main.go, and let's open the file and start adding some code to it. So with that main.go file open, I'm going to go ahead and paste in some code here, and I'm going to step through the code just to explain what's going on here. The first thing I have is a model here that describes the recipe. You can see each of these fields in the struct also correspond to the 4 fields that were created inside of the database. The next function I have here simply creates a connection to the PlanetScale database using an environment variable called DSN as the connection string. Next, I have the handler, which Lambda will use to execute all of the code here. And inside the handler function, I have a section here that will create a connection to the database. I have another section which will run the select star from recipes query and then put those out to a results object. The next section I have here will actually iterate over the rows that was returned from the query and then append them to a slice of recipes here. And then the last section I have here simply takes the recipe slice, converts it into JSON, and prints it out to the console. So I'm back in the integrated terminal, and if you noticed when we were looking at the code, there were a couple of imports that were lit up in red. That's because the mod.sum file has not been created for this project yet. So we can fix that by typing in go mod tidy, and Go will set up the dependencies we need for this project. Next, we're going to build the project specifically for the Lambda environment. I have to set a couple of environment variables here first, though. I'll set go arch for the architecture, and that's going to be equal to AMD 64. Then I need to set go OS, which is the operating system we're going to build for. We'll set that to Linux. And then we could type in go build. We're going to set an output folder of dist/main and a period because we want to build every Go file in this project. Okay, so there's no output, which likely means we successfully built the project. If I cd into the dist directory and perform an ls, you can see we have a single main file, which is the executable binary that we will zip up and send to AWS. So the output directory is open here in Finder. I'm simply going to right-click on the binary and select compress main. And this is going to create a file called main.zip, which is going to contain the file we need to upload into AWS. Okay, so I'm at the AWS console, and I'm going to use the global search to type in Lambda to find the Lambda service. I'll go ahead and select that from the list to head over there. And then I'll click Create Function to start the process of creating a new function. Now, we can leave most of these options here as defaults, but we need to give the function a name. So I'll say PlanetScale AWS KMS demo. And then I'm going to change the runtime to go1.x since that's the language we're using for this Lambda function. I can scroll down to the bottom and click Create Function. Okay, now we can upload the zipped folder that we created in the previous section. Under Code, Code Source, I'm going to select Upload From and then Zip File. And then I'll click the Upload button to open the Finder to find that zip file that we created earlier. Okay, that zip file was selected. I'm going to go ahead and click Save, and the code was successfully uploaded. There are a couple more tweaks we need to make here before we can test this entire flow. The first one is if you scroll down a bit under Runtime Settings, the default handler is set to Hello. This needs to be set to the name of the binary. So I'm going to click edit, and then I'm going to change this to main since that's what the built binary was called, and then click save. Next, I'm going to select configuration and then environment variables from the left-hand side and click edit. I'm going to add environment variable. DSN is the key, and then the value is going to be the connection string for your PlanetScale database. I'll go ahead and paste mine in and click save. Now we can test the function by selecting the test tab here and then clicking the test button. Provided everything was successful, you should have a green alert box that appears that the execution results have succeeded. If I drop this down and scroll down to the log output, we can see there are those 3 rows that we had created in the first step of this tutorial. Now, before leaving Lambda service, one of the things you're going to have to grab to set up KMS is the execution role for this particular function. We can find this in the configuration tab under permissions, and take note of the role name here as we're going to need this in the next step. Now let's take a look at how we can encrypt our environment variables using the KMS service. I'm going to use the search again and search for Key Management Service and select it from the list. Then under Customer Managed Keys on the left-hand side, I will click Create Key. Now KMS does let you create a couple of different key types. There's symmetric and asymmetric, both of which can be used to encrypt and decrypt data. However, asymmetric keys are often used when you need to download the public key to encrypt data from somewhere outside of AWS. Since we're working completely within AWS, I'm going to leave symmetric selected. Key usage can remain as encrypt and decrypt, and I'll click Next. Next, we have to give the key a name. I'm going to name this PlanetScale. AWS KMS demo key. And you can optionally give your key a description and assign it a set of tags. I'll just click Next. Next, we have to select the users that have permissions to administer the key. These users will be able to modify the settings for the key that's created in KMS. If you don't see your name in the list already, use the search box to find it and then check the name for your user. Scroll down to the bottom and click Next. And now we need to define the key usage permissions. This is the user or role that has access to utilize the key to encrypt or decrypt information. This is where you're going to want to use the execution role from the Lambda function that was grabbed from the previous step. Mine was PlanetScale, AWS KMS demo role. So I'll select that, scroll to the bottom, and click Next. And then finally, you'll be given a set of options that you can review and confirm. Go ahead and click Finish. So we're back over in our Lambda function, and what we're going to do is encrypt the environment variable using the key that was created inside of KMS. Scroll down to the Configuration tab and select Environment Variables and click Edit to edit the variables. Now, if you drop down this toggle that says Encryption Configuration, check the box that says Enable Helpers for Encryption at Transit. Once I do this, you'll notice an Encrypt button appears next to the key and value. If I click Encrypt, I'll be given the option to select our demo key that was created in the previous step. And what this is going to do is encrypt that value. Now, one thing I want to call out here is this decrypt secrets snippet. If you expand this, you'll be given a code sample that can be used to decrypt the key. If you're following along, take note of this code as we're going to be using it in just a moment. I'm going to collapse this and then click encrypt. And you'll notice the value has been changed to an encrypted version of our connection string. Scroll to the bottom and click save. Now, if I try and test this function again, you'll notice the execution result is now set to failed because the function does not know how to connect to our database in PlanetScale. This, although encrypted, is not a connection string that the code can actually recognize. So now we need to update the code so it decrypts that value before it tries to connect to the database. Back inside of VS Code, I'm going to paste in the first section of that snippet that was pulled from the AWS Lambda service. Okay, so I've pasted this in and I've saved it, and what you'll notice is there's an init function has been added. Within the Go programming language, if init is recognized within a specific Go module, this function will automatically be called before any other code is run. And if we take a look at this code, this is what's actually going to create the KMS client and then pull down the value of that key and decrypt it for use. Once everything has been decrypted, the value will be stored in this DSN string. So we have to scroll down to this get database function and update the section here that's calling the environment variable DSN and just change it to DSN, which is the name of the variable. Now, once I save this, you'll see there are a couple of dependencies that have been added here. So we'll also need to run go mod tidy again. My integrated terminal is open again at that project. I'm going to run go mod tidy. And then I'll run the command to build the project once more. Back in Finder, we need to zip the binary up again. So I'll delete this. Right click and compress main again. And let's head back into AWS to upload this function once again. Okay, so I'm back in the Lambda service. I'll scroll down to the code source section again, select upload from zip file, and then I will select the zip file once more to upload it. Okay, the function has successfully been updated. Let's select the test tab and click test one more time, and our results have succeeded. If we look, the 3 rows that were created earlier are returned once again. However, this is using the encrypted version of the connection string from the environment variables, which was then decrypted using the key from KMS. After watching this video, you should have a good understanding on how and why you'd want to use KMS to secure your connection strings in Lambda. For more guides and tutorials, visit us at PlanetScale.com and check out our blog and documentation portal where we're adding new content all the time. I'll see you in the next one. Bye-bye.